In a 4-strand audio cable, the standard usage for each color is as follows. Red is typically used for the right positive signal. Green is typically used for the right negative signal. White is typically used for the left positive signal. Black is typically used for the left negative signal. Understanding the color code is crucial for ensuring proper audio signal transmission and preventing any phase issues or signal degradation. When working with audio equipment, it is important to maintain consistent polarity throughout the entire system. Using the correct color code helps achieve this. The red wire carrier is the positive polarity signal for the right audio channel. The green wire carrier is the negative polarity signal for the right audio channel. The white wire carrier is the positive polarity signal for the left audio channel. The black wire carrier is the negative polarity signal for the left audio channel. It is essential to follow this standard to avoid any potential problems with your audio setup. Connecting the wires incorrectly can result in a reversed stereo image where the left and right channels are swapped. This can significantly affect the listening experience and make it difficult to accurately perceive the soundstage. Additionally, incorrect wiring can sometimes lead to signal cancellation or distortion, reducing the overall quality of the audio. When connecting audio cables, always double-check the color coding to ensure that each wire is connected to the correct terminal or input. It is also a good idea to use a multimeter to verify the polarity of each wire, especially if you are unsure about the color coding. A multimeter can help you identify the positive and negative terminals by measuring the voltage difference between them. By following the standard color code and using a multimeter to verify a polarity, you can ensure that your audio system is wired correctly and that you are getting the best possible sound quality. Remember that variations may exist in specific applications or with certain manufacturers, so always refer to the product documentation or consult with a qualified technician if you have any doubts. In some cases, custom wiring schemes may be used, but these are typically documented and should be followed carefully. When working with audio equipment, safety is paramount. Always disconnect the power supply before making any connections or modifications. This will help prevent electrical shocks and ensure your safety. Additionally, use appropriate tools and techniques to avoid damaging the wires or connectors. Stripping the insulation too far back can expose the bare wire and increase the risk of short circuits. Conversely, not stripping enough insulation can result in a poor connection and signal loss. When soldering audio connections, use a high-quality solder and soldering iron. Ensure that the solder joint is clean and shiny to provide a good electrical connection. Avoid using excessive solder, as this can create bridges between adjacent terminals and cause short circuits. After soldering, inspect the connections carefully to ensure that there are no loose strands of wire or any other potential problems. A magnifying glass can be helpful for this purpose. Proper cable management is also important for maintaining a clean and organized audio setup. Use cable ties or other fasteners to bundle the wires together and prevent them from becoming tangled. This will make it easier to trace the wires and troubleshoot any problems that may arise. Additionally, avoid running audio cables parallel to power cables, as this can introduce noise and interference into the audio signal. If it is necessary to run audio and power cables in close proximity, use shielded audio cables to minimize the risk of interference. Shielded cables have a layer of conductive material that helps block electromagnetic interference from external sources. This can significantly improve the signal-to-noise ratio and reduce the amount of hum or buzz in the audio signal. When selecting audio cables, consider the quality of the conductors and connectors. High-quality cables typically use oxygen-free copper conductors, which offer excellent conductivity and corrosion resistance. The connectors should be durable and provide a secure connection. Gold-plated connectors are often used in high-end audio equipment because they offer superior corrosion resistance and improve the signal transfer. The length of the audio cable can also affect the signal quality. Longer cables are more susceptible to signal loss and interference. Therefore, it is important to use the shortest cable length possible to minimize these effects. If you need to run a long audio cable, consider using a balanced connection. Balanced connections use 3 wires, 2 signal wires and a ground wire. The two signal wires carry the same audio signal but with opposite polarity. At the receiving end, the signals are inverted and combined, which cancels out any noise or interference that has been picked up along the way. Balanced connections are commonly used in professional audio equipment because they offer superior noise rejection and signal quality. In addition to using balanced connections, you can also use other techniques to reduce noise and interference in your audio system. One common technique is to use a ground loop isolator. Ground loops occur when there are multiple ground connections in an audio system, which can create a circulating current that causes hum or buzz in the audio signal. A ground loop isolator breaks the ground connection between two pieces of equipment, which prevents the circulating current from flowing and eliminates the noise. Another technique is to use a power conditioner. Power conditioners filter out noise and interference from the AC power supply, which can improve the performance of your audio equipment. They also protect your equipment from power surges and spikes, which can damage sensitive electronic components. When troubleshooting audio problems, start by checking the connections and cables. Make sure that all the connections are secure and that the cables are in good condition. Look for any signs of damage, such as frayed wires or bent connectors. If you suspect that a cable is faulty, try replacing it with a known good cable. If the problem persists, try swapping the inputs and outputs to see if the problem follows the equipment or the cable. If you are still unable to identify the source of the problem, consult with a qualified technician. They have the expertise and equipment to diagnose and repair complex audio problems. Remember that audio systems can be complex and require careful attention to detail. By following the best practices for wiring, cable management, and troubleshooting, you can ensure that your audio system is performing at its best. The information provided here offers general guidance and may need to be adapted based on specific equipment and circumstances. Always consult with a qualified technician or refer to the product documentation for detailed instructions. Building upon the fundamental color code, it is beneficial to delve deeper into the applications and nuances of 4-strand audio cables. These cables are frequently employed in scenarios where stereo audio signals need to be transmitted along with a common ground. Examples include connecting headphones to audio sources, wiring small speaker systems, and creating custom audio interconnects. Understanding the precise function of each wire color is essential for achieving optimal audio fidelity and preventing potential issues such as phase cancellation or signal distortion. Firstly, let's reiterate the standard color assignments. Red is designated for the right channel's positive signal. Green is designated for the right channel's negative or ground signal. White is designated for the left channel's positive signal. And black is designated for the left channel's negative or ground signal. These assignments are widely adopted to ensure consistency and ease of troubleshooting within audio systems. Secondly, when working with these cables, it's crucial to maintain polarity. Polarity refers to the correct orientation of the positive and negative signals. If the polarity is reversed, the audio signal can be negatively affected, leading to reduction in bass response, a diffuse stereo image, or even complete signal cancellation. To avoid polarity issues, carefully match the colors of the wires to the corresponding terminals on the audio equipment. Many audio devices have color-coded terminals or markings to indicate the correct connections. Thirdly, consider the impedance of the audio equipment. Impedance is a measure of the resistance to the flow of alternating current. Mismatched impedances can result in signal loss, distortion, or even damage to the equipment. While 4-strand audio cables themselves don't directly affect impedance, it's essential to ensure that the impedance of the connected devices is compatible. For example, if you're connecting headphones to an amplifier, make sure that the amplifier's output impedance is suitable for the headphone's impedance. Many headphones have an impedance of 32 ohms, while others may have an impedance of 300 ohms or more. The amplifier should be able to drive the headphones without distortion or signal loss. Fourthly, shielding is an important factor to consider, especially when running audio cables in environments with potential sources of interference. Electromagnetic interference, or EMI, can be generated by electrical equipment, radio transmitters, and other sources. This interference can be picked up by the audio cable and introduced into the audio signal, resulting in noise or hum. Shielded audio cables have a layer of conductive material, typically braided copper or aluminum foil, that surrounds the signal wires. This shield helps to block EMI and prevent it from interfering with the audio signal. When running audio cables in close proximity to power cables or other potential sources of interference, it's highly recommended to use shielded cables. Fifthly, cable length can also affect the audio signal quality. Longer cables tend to have more signal loss and are more susceptible to interference. Therefore, it's best to use the shortest cable length possible to minimize these effects. For short runs, the cable length is usually not a major concern. However, for longer runs, it's important to use high-quality cables with low signal loss. In some cases, it may be necessary to use a balanced connection to maintain signal quality over long distances. Sixthly, when connecting 4-strand audio cables, it's crucial to use proper techniques to ensure a reliable and secure connection. This involves stripping the insulation from the wires, twisting the strands together, and then soldering or crimping the wires to the appropriate connectors. Soldering provides a strong and reliable connection, but it requires skill and experience to do it properly. Crimping is a faster and easier method, but it's important to use the correct crimping tool and connectors to ensure a secure connection. Seventhly, consider the type of connectors used in the audio cable. Common connector types for 4-strand audio cables include 3.5mm or 1/8 of an inch, TRS connectors, RCA connectors, and XLR connectors. TRS connectors are commonly used for headphones and portable audio devices. RCA connectors are often used for connecting audio equipment to stereos and home theater systems. XLR connectors are typically used for professional audio equipment and balanced connections. The choice of connector depends on the specific application and the type of equipment being connected. Eighthly, proper cable management is essential for maintaining a clean and organized audio setup. Use cable ties or other fasteners to bundle the wires together and prevent them from becoming tangled. This will make it easier to trace the wires and troubleshoot any problems that may arise. Additionally, avoid running audio cables parallel to power cables, as this can introduce noise and interference into the audio signal. Ninthly, when troubleshooting audio problems, start by checking the connections and cables. Make sure that all the connections are secure and that the cables are in good condition. Look for any signs of damage, such as frayed wires or bent connectors. If you suspect that a cable is faulty, try replacing it with a known good cable. If the problem persists, try swapping the inputs and outputs to see if the problem follows the equipment or the cable. Finally, remember that audio systems can be complex and require careful attention to detail. By following the best practices for wiring, cable management, and troubleshooting, you can ensure that your audio system is performing at its best. The information provided here offers general guidance and may need to be adapted based on specific equipment and circumstances. Always consult with a qualified technician or refer to the product documentation for detailed instructions. By understanding the color code, maintaining polarity, considering impedance, using shielded cables, managing cable length, using proper connection techniques, selecting appropriate connectors, practicing proper cable management, and employ effective troubleshooting methods, you can ensure that your 4-strand audio cables deliver optimal audio performance. Remember that variations may exist, especially with proprietary or non-standard audio equipment, so always consult the manufacturer's documentation for the most accurate wiring information. Understanding these nuances empowers you to confidently connect audio devices and achieve the highest possible audio fidelity. For further insight, always cross-reference information with official documentation and consider the specific application context to guarantee optimal audio signal transmission.